Good morning, dear students. As we all know that tomorrow is 15th August, that is Independence Day. On the occasion of Independence Day, I want to introduce some important or interesting facts about our India to feel proud on. India gave the world its first university, Takshila University, which was there around 700 BC. Now in Pakistan, Snakes and Ladders was inspired from an Indian game called Mokshpat or Moksha Patumu. Another interesting fact is that Indians were the first one to use and invent buttons. And it is quite surprising that India gave shampoo to the world first in 1762, and the word shampoo was actually derived from the Sanskrit word champu, which means massage. Dear students, how are you all? In previous class we discussed about velocity. Velocity is equal to displacement upon time, right? Now we see that during uniform motion along a straight line, the velocity of an object remains constant, means no change, and it does not change with time. But when we talk about non-uniform motion, the velocity of the object varies, right? The velocity may have different values at different interval of time. So the rate of change of velocity is called acceleration. Acceleration is the change in velocity upon time taken. Change in velocity means the difference between final velocity and initial velocity. So final velocity is denoted by V and initial velocity is denoted by U. So the formula for acceleration or the mathematical expression is that A equals to V minus U upon T, and the unit is meter per second square. As we know, the unit of velocity is meter per second, but we have one more second here, so the unit is meter per second square. Now if we take an example, in an example, starting from a stationary, Satvik attained a velocity of 20 meter per second in 4 seconds. While completing for a race, calculate acceleration. So here we see that in numerical, starting from an stationary means the initial velocity is 0, right? So we put here initial velocity u equals to 0. If anything is stationary, it means the velocity is 0. So initial velocity is 0, final velocity v is given that Satvik attains a velocity of 20 meter per second in 4 seconds. So finally he attained a velocity of 20 meter per second. So v equals to 20. Time taken is 4 seconds. We write here 4 seconds and put these values in the formula of acceleration. A equals to v minus u upon t. So final velocity 20, initial velocity is 0 and time taken is 4. So we get 5 meter per second. We see the distance time graph. The change in the position of an object with time can be represented on distance time graph. Here x-axis is showing the time period and y-axis representing the distance, and if we get a straight line, it means an object is moving in a uniform speed. And we can also calculate the speed of an object by this graph. Suppose we take 2 points on the line, that is A and B. Let the point A and B corresponds to times t1 and t2 and the respective value of distance be s1 and s2, right? And draw a line parallel to x-axis from point A. From point B, draw a line parallel to the y-axis. So here we see that from point A, we draw a line parallel to x-axis, and from point B we draw a line parallel to y-axis. These two lines meet at point C, right? So we get a triangle ABC. So we know that the formula of speed equals to distance upon time. So distance here is, if we calculate the distance from moving from A to B, it will be S2 minus S1, and the time will be, as we move from A to B, it will be T2 minus T1. So according to the formula, we put here S2 minus S1, the distance, and time is T2 minus T1. The value of S2 is 30, S1 is 20, T2 is 60, and T1 is 40. So here we get 10 upon 20, that is 0.5 meter per second square. So in this way we can calculate the speed of an object moving in uniform speed, right? And another is a graph showing an object moving in non-uniform speed. If an object does not have cover equal distance in equal interval of time, then we get a curved line rather than a straight line. So this is a graph of non-uniform speed.